beginning of the quantum computing class, but I put it at the end to avoid confusion. Just to show you that you don't need to know quantum mechanics or whatever. It's just purely linear algebra so far, right? But now we study Bloch sphere, which you will appreciate more and also not go into trouble, fall into the pitfall. So let's first understand what is the general representation of a qubit. Psi equal to what? What is the general 1 qubit equation? If the basis is 0 and 1? Alpha 0 plus beta 1. Thank you. And alpha and beta are complex numbers, right? So I can say alpha may be equal to its magnitude, e to the power I alpha. Beta equals to its magnitude, e to the power I beta. Oh, sorry, I should say delta alpha, delta beta, which are their angles, right? Alpha. Delta alpha, delta beta. Is that okay? I just represent a complex number as the magnitude times e to the power I angle. Make sense? So let me ask you, how many degrees of freedom do we have? It means that to fix the state, I need to fix how many parameters so that I have a definite state for what I just showed you. Huh? You say free? Which free? What are you going to fix if it is free? Okay, I'm going to stop you because you say 4 parameter, and what you're going to say is the next step. So yes, 4 degrees of freedom. Very good. So it has 4 degrees of freedom because I need to fix alpha magnitude, beta magnitude, alpha angle, and delta beta. All right? Once I fix these 4 parameters, then I'm done. That is the unique state that I have. Okay. And then he was too fast. He said what? He said, but we're doing quantum computing. We're doing quantum mechanics. The magnitude of the state needs to be 1. Okay? Which means what? Alpha square plus beta square equals to 1. Right? So you don't have the freedom to choose arbitrary alpha magnitude and beta magnitude. Once you pick alpha, I know what's the beta magnitude right away because of this constraint. Make sense? Okay, so now it has only 3 degrees of freedom. Okay, good. But I'm going to show you that we are going to reduce it to 2 degrees of freedom. Okay, but now we have 3, okay? So because of this, then, if you say alpha square plus beta square equal to 1, so it has 1 parameter, it can be fixed by 1 parameter, then I can do many different types of transformation. And one type is that I let alpha equals to alpha magnitude equal to cosine theta divided by 2, and beta equals to sine theta divided by 2. Sine square plus cosine square equal to 1, right? So this satisfies the requirement. And I also only has 1 parameter. And that parameter is theta. Right? So instead of fixing alpha and then use 1 minus alpha square and take square root to get the magnitude of beta, I can also just give a theta. And then alpha is cosine theta divided by 2, and beta is sine theta divided by 2. That will also fix the state. Are you okay with this? Because every alpha is going to correspond to a theta in cosine theta divided by 2, right? If I say, oh, my alpha magnitude is 0, then I say, okay, then your theta is pi. Because pi divided by 2, cosine pi divided by 2 is 0, right? That is just like what you pay. And then, of course, beta needs to be 1, right? Because alpha squared plus beta squared equal to 1. And then it is still true because sine pi divided by 2 is 1. Do you see that? I'm doing the same thing as you. Okay? So that is one parameter, right? So we did not change anything. Now with that, then I can say psi, any general state, right, is equal to cosine theta divided by 2e to the power I delta alpha 0 plus sine theta divided by 2e to the power I delta beta. What I'm doing is just repeating this equation. Psi 0 to alpha 0 plus beta 1. Alpha 0 is magnitude of alpha, now is cosine theta divided by 2 e to the power I delta alpha. Beta is magnitude of beta, which is now sine theta over 2, and then times e to the power I delta beta. After doing all this, it looks trivial. That's all I'm doing, right? Is that okay? Okay, then I continue to do some manipulation. So I'm going to factorize out e to the power I delta alpha plus delta beta, the whole thing divided by 2. Because of this factorization, this will become cosine theta divided by 2, not change. But I have factorized out alpha, delta alpha plus delta beta, right? Then in order to make it the same as before, this need to be I delta alpha minus delta beta divided by 2. So that when I multiply this to here, delta beta is going to get cancelled, right? Because this is plus, this is minus. And alpha will add together, it become e to power delta alpha. So it's the same as this term. Right? You just plug in, you will see that. And similarly, for the second term is sine theta divided by 2, e to the power I. But now I need to keep beta, so that's why I have negative delta alpha plus delta beta divided by 2. And I forgot 0 and 1 here. And also what? I missed which one? Oh, the line above, thank you. I missed 1 here. Is this okay? I just playing math, right? Okay, so now this is what I'm going to do. I define this one, gamma equal to delta alpha plus delta beta divided by 2. I also define phi, a new variable, equals to delta beta minus delta alpha divided by, no division, just, is that right? Yeah, just delta beta minus delta alpha. So this equations becomes what? E to the power I gamma times cosine theta divided by 2, e to the power negative phi divided by 2i, plus sine theta divided by 2, e to the power, okay, I keep forgetting the 0, plus e to the power I phi divided by 2, 1. Am I right? Because this is delta beta, yeah, delta beta minus delta alpha, so it's phi. This is negative delta beta minus delta alpha, so negative phi, right? Do I make any mistakes? Is that okay? How many parameter we have? We did not do anything. Still, it has the degree of freedom equal to 3, and we have 3 parameters. We need to fix these 3 parameters to fix the states. So what are the 3 parameters? What are the 3 parameters that after I plug in, then I fix the states of the qubit in this equation? Theta, phi, and gamma. It's a 3, right? Still 3 degrees of freedom, right? But gamma is what we call the global phase. And we are going to ignore it. Gamma is e to the power I in front of the whole wave function. We can ignore it. It's not important. If the whole system has a global phase, you don't have any physical meaning. Okay, so why? Let's take a look. Okay, start from here. Right, let me repeat. Gamma is the global phase, has no physical significance. Okay, he has no physical significance. Why? For example, how do you find the expectation value of psi on a measurement? How do you find the measurement? Do you still remember how to expect it? After all the quantum computing or quantum mechanics, if you don't see it, don't touch it, it's irrelevant to you until you measure it, right? So, for example, I want to find the spin of the qubit. When I measure it, what is the equation? Do you remember? Yeah. It's just sandwich, right? Bra psi, m, and then cat psi. Remember this? If you forgot, now it's time, just treat it as new piece of knowledge. Okay, that's you find the expectation value, the FH value when you do the measurement. Okay, now, if psi has a global phase, okay, then what happened? Psi will become what? E to the power I gamma psi, right? Then how about the cat version of psi becomes what? Go back to our bracket notation. What is the dual correspondence of this guy? For the cat, it becomes still bra, yeah? But then for the complex number, it becomes the complex conjugate. So yes, it's the negative, right? Because complex conjugate is negative I. Okay, so what is the expectation value? Let's say I add a global phase to it and then I measure again. It is psi e to the power negative gamma m e to the power I gamma psi, right? But e to the power I gamma are just numbers. I can group them together, right? Again, what we're doing is row vector times a number times a matrix times a number times a column vector. So this one multiplied together equals to what? What is e to the power negative r times e to the power ir? Negative ir times e to the power ir. Just e to the 0, very good, and which is 1, right? So it's unchanged. Here is just to show you that what we care the most about, which is the measurement, does not depend on the global phase. So global phase is not important in this sense. Similarly, what we always care about is the inner products. Remember, this is an inner product space. If you still remember, we talk about linear algebra. Actually, did I talk about inner product space? We talk about Hilbert space, right, which is an inner product space. We define inner products, remember? Inner products is very important because with inner products, we can also define the distance, the length of the vector, and their distance, actually. Okay? Does inner product depends on the global phase? Again, it doesn't, because inner product is nothing but just removing m, right? Although you might have different, the length, right? The length, right? The length doesn't depend on the global phase. And same for two vector for inner product if we add the same phase to them. Okay? Okay, so then what does it mean? So for 1 qubit, we ignore e to the power I gamma. We can write it as cosine theta divided by 2, e to the power negative I phi divided by 2, 0 plus sine theta divided by 2, e to the power I phi divided by 2, 1. This is the general expression of a 1 qubit system. How many parameters it has? Two, theta and phi. It has a degree of freedom equal to 2. So if it is 2, I can put it on a 2D space. But remember, this is a complex. No. Now I'm saying the wrong thing. If I have 2, I can put it in a 2D space because it only has 2 degrees of freedom. In its real space, it's a complex space we cannot see. Right? Remember, this is a complex number. This is a complex number. You cannot map it in the real space that we're living in. So you cannot have a table and put a qubit. But however, I have a 2 degrees of freedom also, because theta and phi, once I fix them, I know which state it is. So what I can do is, it turns out that this one is just look like a spherical coordinate. It turns out that theta is just the angle from the North Pole to here, if this is the state. And phi is just the azimuthal angle from along the equator. So what we are trying to do is not really try to say that the qubit live in our 3D space. This is very important. The qubit does not live in our 3D space, but we embed this C2 space in our 3D space. So we make it so that we have a unit sphere on this 3D space. Every point on the sphere corresponds to one state in the space that we cannot see. For example, because every point has a theta and also phi. It's so simple. Every point on this unit sphere has a theta and phi. And this maps very well to this equation. And that's why you should not get confused. People get confused. If you think that this is in 3D space, right, what is 0 plus 1? You accept this for now. I say 0 is on the top of the sphere. 1 is at the bottom, and they are all vector. What is 0 plus 1? You think it's 0, right? Nothing, right? But is that correct? No, right? Because you only think that is 0 because if you think that it's a real vector in our 3D space, then of course one pointing up, one pointing down, adding together is nothing. But again, no, 0 plus 1 is a state on the equator. Okay, so do not think that this is a vector in our 3D space. That is the thing that confuses people a lot. We only embed, right? This is a key word. It has a, just like the map, you have our Earth is a sphere, and you somehow can map it to the 2D table, right? When you see the map. There is a kind of mapping. You embed it in this 2D space, right? So this is similar. And the best way to further understand this is to try to understand the extrema for now. Okay, so let me ask you. When theta equals to 0, phi equal to 0, where is the state when theta equals 0, phi equals 0? Top. Because theta is 0, you have 0 angle from the North Pole, right? So you must be at this point. And then your phi equals 0, just think that how far it is away from this axis, but it really doesn't matter. Because you are at North Pole, even you keep turning, remember you are just a point. You are not a human that you can face a certain direction. You are just a point. No matter how you turn, you are still the same state. Right? So this should be 0. And let's check if this is the case, right? So I will say this is the North Pole. Then we check. Psi equals to cosine theta divided by 2 e to the power negative I phi over 2, 0 plus sine theta divided by 2 e to the power I phi over 2. This was the equation I gave you, right? And what is this? Let me just plug in. This is nothing but just cosine 0 e to the power I 0 divided by 2, 0 plus sine 0 divided by 2. Let me still put divided by 2. E to the power I 0 divided by 2. Right? I forgot one. So sine 0 is 0. Cosine 0 is 1. And e to the power 0 is 1. So this is just equal to 1, 0, which is 0. Only this term left. Make sense? So it's correct. If you plug in this equation, indeed is equal to 0. Right? So for 0 state, theta equal to 0. Now let's check another thing. What if theta equal to 0 but phi equal to, let's say phi not? Just give another number which is not 0. Then psi, and as we just discussed, right, it should still be 0, right? Because based on this figure, when theta is equal to 0, I don't care what is the phi, what phi is, it should still be at this point, right? So I should get 0, but is this true? Let's plug in and see. This is equal to cosine 0 divided by 2 e to the power I phi negative I phi over 2, 0 plus sine 0 divided by 2 e to the power I phi log over 2, 1. Again, sine 0 is 0. Right? This term is just 0 because sine 0 is 0. So what do I get? I get e to the power I negative I phi divided by 2, 0. Oh, It's not the same. I have this. But can I say that the same actually? The difference is just that it has an extra phase. Again, I will say what? If you have an extra global phase, it doesn't matter. And that's what we have said earlier. We already dropped the extra phase. So actually, every point on this Bloch sphere corresponds to infinite number of states, but their difference is only by a global phase, e to the power I something. Okay, so this is still the same as this one. Okay, same as 0 because global phase is immaterial, right? Right? We don't care about global phase. Right? So now you understand every point in Bloch sphere on the surface of Bloch sphere correspond to one quantum state, but actually more than that. That quantum state times any global phase, e to the power I something. Okay, they all correspond to the same point, but doesn't matter because we're talking about 1 qubit, that is the global phase. It has no physical significance. And that goes back to, if you remember when I asked you to diagonalize the sigma y matrix at that time, most of you will get different answer, but the only difference is just that you have a different global phase. But you always proportional to 1i, right? 1, 0 plus I0, I1. But some of you may have I0 plus 1, 1, which just have a difference in global phase than the first one. Any questions? Yeah. Phi, or this one, is still at the top, right? If you look this, look geometrically, because it say theta equal to 0, and this is the only point has theta equal to 0. Other point has theta larger than 0 to 180, right? So it's still at the same point. So they are exactly the same. So that's why each point corresponds to many states, but they only differ by a global phase. Okay. Okay, so let's continue to do more exercise. What about theta equal to pi and phi equal to 0? Based on this, theta equal to pi, what does it mean? All the way to 1, right? So I should expect to get 1, and of course I should. Let's just check, is psi equal to cosine pi divided by 2, because this is theta, e to the power negative I0 divided by 2, 0, plus sine pi divided by 2 e to the power I0 divided by 2, 1. And the first term, pi cosine pi over 2 is 0, right? This is 0. So I have 1. Because e to the power 0 is 1, sine pi over 2 is 1, so 1, which is correct. Okay? So to describe 1, I just say theta equal to pi. Okay? Let's look at another example. What if it is theta equals to pi divided by 2 phi equal to 0? Based on this, what is this? Pi, theta equal to pi divided by 2 means that it is on the equator, right? Pi over 2, 90 degrees. And then phi equal to 0 means you measure from this point, is 0. Then it means you are at the plus state. Okay? So let's see if this is correct. This is case 1. Psi equal to cosine. This time is pi divided by 4 because it's theta divided by 2. Theta is pi divided by 2, so it's pi divided by 4. E to the power negative I phi over 2, which is 0. I just put 0 over 2. 0 plus sine pi divided by 4 e to the power I 0 over 2, 1, right? If you forgot, cosine pi over 4 equal to sine pi over 4, 40 degrees. So it is 1 over square root 2, 0 plus 1. which is exactly the plus state. Can you follow? Anyone has a question? What I did, I just substitute this, right? And e to the power 0, e to the power 0 give you 1. Sine pi over 2 equal to cosine pi over 2. Sine pi over 4 equal to cosine pi over 4, which is sine 45 degrees, is 1 over square root 2. So I just factorize it, 0 plus 1, which is the plus state, which is exactly what we have here. So my label was correct, right? Let me finish the last one. What about theta equal to pi divided by 2, but phi equal to pi divided by 2? This time, theta is pi divided by 2, but I need to rotate this by pi divided by 2, so I should get this state, which is an eigenstate of sigma y, right? So let me just plug in. This is equal to cosine pi over 4, same as earlier, but this is e to the power negative I pi over 4, 0, plus sine pi over 4, e to the power I pi over 4, 1. It's just pure substitution. Pi over 2 substitute into phi over 2, so it becomes pi over 4, right? So I need to do some manipulation. You will see that first the cosine pi over 4, sine pi over 4 is 1 over square root 2. I take it out. And at the same time, I take out e to the power I pi over 4. When I take out I pi over 4, the first one, 0, is just 0, right? I take out the whole thing, e to the power I pi over 4. But now I take out this whole thing, I will need to just make sure that you will go back to I pi over 4. I need to make this I pi over 2, right? So that I pi over 2 minus I pi over 4 will give me I pi over 4. Right? Pi over 4 is equal to pi over 2 minus pi over 4. Right? And then you just do some math. This is equal to e to the power negative I pi over 4. 1 over square root 2, 0. E to the power I pi over 2 is actually I, because cosine pi over 2 plus I sine pi over 2. This is just I. Now you see that it's not exactly the same as what I wrote here, but is this okay? It is, because they only have a global phase difference of e to the power I pi over 4, right? And this point indeed represents infinite number of points that is differed by a global phase. Okay? So I will stop here. Let me know if you have any questions.